Alright guys, so just going to look at a couple more examples dealing with set notation, intersection, union, and add one more little piece in, the complement. Alright, so let's start with these. We've got our universal set, which you can see right here is all one-digit numbers. So we could write out our universal set as being 0, 1, 2, 3, 4, 5, 6, and so on and so forth. We've got P, which is X such that it goes from -2 to 6, but you can see right here X is an element of the positive integers. So therefore for P, it could be 1, 2, 3, 4, 5, or 6. Those are the only numbers possible. Alright, then we've got M, and M is such that X is between 2 and 7. So 2, 3, 4, 5, 6, 7. Alright, so my first question is, can we make this statement? Is P a subset of M? Hopefully you figured out that P is not a subset of M because there is a piece of P, the number 1, which is not a part of M. So therefore P is not a subset of M. We could say, bloop, bloop, bloop. We could say that P is a subset of U, right? That because U is one-digit numbers and P is a subset of them. All right. Okay, let's move along. Let's look at our Venn diagrams. We're going to do a Venn diagram of, so here we go. Here is our universal set, which is U. Alright, now inside of this, we're going to put P. P is 1 through 6. So that represents 1 through 6. That's P. And then we've got M, which overlaps in great part with P. Right? So then we've got M right there. So this is a Venn diagram of P and M inside of U. P and M overlap, but neither one is inside of the other. Alright, so one of the things that we learned last class was the intersection. P intersect M. So what are the values that are represented by P intersect M? Well, you'll remember that P intersect M are these numbers, the ones that are in the overlapping section. So in this situation, you can see that P has 2, 3, 4, 5, 6, and so does M, 2, 3, 4, 5, 6. So P intersect M is 2, 3, 4, 5, and 6. Okay, similarly, we had one that looked like this. It was P union M. And remember, the union basically said that anything that was part of either one is now part of the whole. So P intersection M, I'm going to do in blue, and that's everything that's inside of both of them. Okay, so all of this, including the intersection. Okay, so in this case, you'll notice that anything that was part of P is part of our union. So all of those numbers, 1, 2, 3, 4, 5, and 6 are part of that union. Plus anything that's part of M. Now, you notice that we've already got 2, 3, 4, 5, and 6 because those were part of P, but we need to add in number 7. So that's the intersection. Now, I want to add in one last thing, like I mentioned. I want to add in something called the complement. Okay. Okay, now the complement is all the numbers inside of U that are not in one of the other sets that we have. So for example, if I were to write P apostrophe, the apostrophe there represents the complement. So because the one-digit numbers includes everything from 0 up to 9, right? Where I guess I should have said positive one-digit numbers, so or non-negative 0 numbers, so 0 up to 9. Then the complement of P, or P apostrophe, would include all of those numbers that are not part of P. All right, so we'd start with 1. Then we notice that 2, 3, sorry, not 1. Not 1. We're going to start with 0. Okay, and then we notice that 1 is a part of P, so it's 2, 3, 4, 5, 6. So we'll skip up to 7, 8, and 9. So those are all the numbers that are not a part of P. So they are called the complement. All right, so what I'd like to do is let's do a union for one of these complements. All right, so let's say that we want to do M union intersection, M intersection, sorry, should not have that there. So M intersection complement of P. So that's asking for the intersection of things that are part of M but not part of P. So you can notice that by looking at the numbers that we have, right? M was 2, 3, 4, 5, 6, 7, where not P was 0, 7, 8, 9. So the only number that actually fits is 7. Now, where would that be in the diagram? Well, that would be here in the diagram where we have the not P and M. So it's got to be inside this circle right here, but not in P. Notice this part of the circle is in P. So therefore, that we just found, the M intersection complement of P, is this section right over here. All right, so this section right here is the M intersection not P that we just found. Okay, so hopefully this will be helpful as you start to look at some other things with Venn diagrams, especially the complement. All right, that's all for today. Hasta luego, chicos.